Now, getting back to this is now part two of the injection system design. All right. Now, if you've got an 8-liter engine that's 8-cylinder, that means each one of them pistons, volume wise, at bottom dead center, is 1 liter. All right. So you need to have a fuel injector that can handle that flow rate. For a big block 454, for instance, you have 43 psi at 43.75 GPH, which is gallons per hour. All right. Now, let's say it like this: you divide that into the tree for the lines feeding fuel to each injector. The style of injector you use is a um, resistant variant injector. It has the ability to open that orifice for flow rate based on resistance. Now, what you need to do is you need to find out what the resistance sweep or curve of that injector is. Like, for instance, if it's 0.23 at the bottom end, all right, zero being closed, obviously, and let's say for wide open, it's 3.75. Now, these are not actual numbers. We're using this for sake of conversation. All right. You need to have a reluctance or resistant variant knob, all right, or form of switch. What you can find and make work needs to be able to handle the amperage of all 8 injectors at once, because you'll be running from the ground side, positive tied directly to power. All right, and on the ground side, you wire them together. You can use a what's the word I'm looking for here? Brain fart. um, Junction block, that's the word I'm looking for. All right, but you need to take into account the resistance of that um, um, junction block, and or the length of wire that you have. If it's beyond a certain length, you may need to get little inline resistors to change the resistance, but you might also need to use a different knob. This does take math, but hey, you got the entirety of information known to mankind in your hand, in your pocket at all times, and it's a great time to be alive because of that. All right, now let's say this: you use that resistance knob, you make an armature for it, preferably something that's water resistant, of course, for the knob. But you connect that to a throttle linkage to a um, throttle body. All right, that's of course pedal activated or lever activated to open and close the throttle like a standard vehicle. Now, with the resistance switch on the side of it that's variable resistance, what you do is you set it up in such a way that at idle or closed, the injectors are on, run the power through a relay, not the resistance side, which is on ground side, run the power to a relay, all right, that is activated at ignition, not at accessory, all right. Then what, and if you have HEI distributor, that makes it so much better. It really does, because you have a lot more options. And then when you run into older Chevrolets, you literally have in the fuse box up underneath the dash for like square bodies, you have ACC, IGN, and all these different terminals up there that sometimes they're powered, sometimes they're not. Um, it's kind of a hit and miss. You need to figure out what you got. This is just a general overview. Okay, you take that and you power onto that relay for fuel injectors, as well as you use that to power a secondary relay to power your electric pump. Which, for instance, if you have 43 GPH injectors, you're going to need a 43 GPH um, pump. Along with, if you have a 43 PSI, you need a 43 to 50 PSI pump with a regulator. Regulators are a wonderful thing to have. They truly are, especially the adjustable ones. Holley's got a great selection. So does Bosch. It just depends on how technical you're wanting to get here. Now, what you do is you use that reluctance knob that has variable resistance that you've rigged up for a TPS, basically throttle position sensor. Now, at idle, you're going to need to have that flowing a small amount of fuel. Now, to do that, my suggestion is use a linkage that is adjustable on the TPS or resistance variance knob. All right, so that you have just enough to run the vehicle. Now, there is a now this setup right here is going to be interesting because then what you need to do is you need to take um, a bore and or a drill and tap a bore, usually pretty small, into the throttle blade itself so that it can idle. And on the other side of that, you need to take a my idea is a two-wire electric General Motors vacuum switch, because you can vent manifold vacuum to atmosphere and thereby increase airflow. Then on top of that, all right, you're going to need to bump up the resistance or down the resistance depending on the injectors and knob that you've selected to raise or lower fuel flow. And the reason for doing that is this: you need to have high idle. Now, that's easy enough to do. You have a secondary, or this would be your third relay actually, run to that vacuum valve, and then a wire coming off of that to increase variance or lower variance of resistance for the injectors, which will open and or close them depending on where you need them. Now, this is only a high idle setup. So basically, then what you do is to power that relay as a trigger, you get an adjustable thermal switch, you shove it into the coils of your radiator. There are other options, of course, okay? And you have it set to, let's say the running temperature is 200 degrees. All right, well, if you set that down to about 185, 190, it will cut off high idle, close the valve, and return nominal standard flow rate to the injectors based on throttle position. Now, what that does is you have high idle when you start the vehicle, so it's easier to prime. You don't have to pump the gas because that will literally do nothing unless the injectors are on. But all that does is just continuously spray. You let it sit there for a second, don't touch the gas, hit it, it will run and it'll jump up to high idle. Now, to get the proper high idle, you're going to need to play with vacuum line sizes. Usually not very big. Quarter inch is probably a little big. Um, and you need to adjust it in such a way that when that opens, it also changes the flow rate of the injectors themselves. And in doing so, allows you to maintain that fuel mixture. And this is stuff that can be done with a vacuum valve, vacuum gauge, similar to what you would use on a carburetor. All right. Now, what this would be is a constant injection, electrically activated and varianced fuel injection system. This would not have an IEC. This would not have an O2 sensor. This would be play it by ear. You adjust it like a carburetor. All right. Except it's a little more technical. You got to know what your flow rate is, and you've got to know what your air mixture is. You want to keep that centered. There's a sweet spot. If it's starting to black smoke, you're running too rich. If it's starting to white smoke, you're burning oil. Or no, that's blue smoke. But burning white smoke, that means you're running too lean. All right, so you need to get that in that sweet spot because you can cause all kinds of problems not running a proper fuel mixture. You talk to anybody who builds carburetors, they'll tell you the same thing. But that's the point in having the adjustment for the armature for the variance resistant knob that you'd be using as a TPS. And thereby, in effect, you would have a full blown fuel injection system. Now, this would mirror mechanical injection. There is another way to do it that would require a pulse module capable of holding the voltage of pulse injectors, similar to what this car has. It would have to be set to a nominal pulse setting. Let's say, for instance, 2,000 pulse per minute. Whether that be accurate or not, again, this would take homework. There's a lot of specs on an injector, and you can find a lot about them. Okay, this could also be done with mechanical injectors in the way that I'm about to say. Instead of using a reluctance knob for fuel injector opening, what you would use instead is they have a Bosch, and there are other ones that are of the same style. It is a vacuum manifold pressure actuated um, fuel regulator. Now, what this does is it has a vacuum line that sits on top of it. This car has one. Not necessarily the exact kind I'm talking about, but it functions the exact same way. It's vacuum controlled. All right. You have the most vacuum at idle. At the higher RPMs, you lose vacuum as you go up in your RPM curve. Now, what that does is, think about it like this: running this setup on, let's say, mechanical or pulsed injectors with a non-changing pulse setting. You can get these little modules real cheap off Amazon from Radio Shack, stuff like that. That holds a constant pulse on them so you don't burn them up. Now, for fuel flow, you use that vacuum line. Now, this is where math comes in again. You have to know the volume of your intake, which is difficult. All right. But there's another way of doing it. You just got to play with it a little. All right. It's the hillbilly antics. So you take that vacuum line and you run it where you have maximum vacuum at idle. Now, that's usually a little higher up on the intake, closer to the bottom of the throttle body, which you would still need. But again, this would not have an idle air control in the typical sense. It would use the 2-wire General Motors style vacuum inline vacuum switch that is again off of it offers high idle, and what you do is you vent manifold vacuum to atmosphere, and it pulls air in and increases your airflow. Now, that's where things get really interesting, because that would be on high idle with the thermal switch to control that. But even when that turns off at nominal pressures for running temperature, you would have something else, because not only while that's on and while that's off, if you start to load your engine at idle, it's going to increase the fuel flow. All right, because it's vacuum controlled fuel flow. It also maintains pressure at whatever temperature or pressure you get that set to. If it's a 43 psi, it's going to hold that 43 psi, but it'll lower the 44 GPH, or gallons per hour, higher and lower, so that you would in effect have a vacuum mechanical idle air control. And I really want to try this. I'm going to try on that single cylinder lawnmower. And remember this, the injector style that I'm talking about, they're modular, they're easy to find. Yamaha golf carts use these, E-Z-GOs use these, lawnmowers use these. They are in all kinds of gasoline applications. If you're, to put it into perspective, you've got a 700cc Polaris V-twin Sportsman. This is a 4600cc. All right. Once you break it down in basic math like that, it gets so easy to calculate. And you've got to make sure that you have your fuel air mixture proper, because otherwise it will not run. But I hope you guys enjoyed this, and I'm going to be doing some more videos in the near future. I've got a hydrogen fuel cell that I think would be really interesting. Y'all let me know if you have any suggestions, tips, or tricks. I hope everyone has a blessed day. God bless, guys. Have fun.